Good morning, everyone. We are the group 5, and our topic today is all about the laws of reflection and refraction of light. These laws explain how light behaves when it encounters surfaces or passes through different materials. They are very important because they help us understand how mirrors, lenses, eyeglasses, cameras, and even natural phenomena like rainbows actually work. So before we begin our discussion, here are our objectives for this lesson. First, to define reflection and refraction of light. Second, to state and explain the laws of reflection and refraction. Third, to apply Snell's law to solve problems involving refraction. And lastly, to differentiate between reflection and refraction through examples.
Good day, everyone. Today I'll be discussing about how light behaves. First, light behaves as a wave, and when it interacts with different surfaces and mediums, it results in two main phenomena, which is the reflection and refraction. So, reflection is the bouncing of light on surfaces. For example, is when light hits a mirror. Meanwhile, refraction is the bending of light as it passes from one medium to another. For example, is from air moving into water. These principles are very important because they are the basis of many technologies we use daily, like lenses in cameras and eyeglasses, microscopes in science, and fiber optics used for internet and communication. Now let's go deeper into the key concepts. First, the incident ray is the incoming ray of light that strikes the surface. Next, the normal line is an imaginary line perpendicular to the surface at the point where the ray hits, and the reflected ray is the ray that bounces back off the surface, while the reflected ray is the ray that bends off as it enters another medium. We also have the important angles. So first is the angle of incidence, which is the angle between the incident ray and the normal. Second is the angle of reflection, which is the angle between the reflected ray and the normal. And lastly is the angle of refraction, which is the angle between the refracted ray and the normal. In short, these terms and angles helps us understand and measure how light behaves, whether it is reflected or refracted.
Hello everyone, I will be discussing now the two fundamental concepts in light, which are the laws of reflection and the laws of refraction, or also known as the Snell's law. Let's have first the laws of reflection. Reflection is what happens when light bounces off a surface, right? Like a mirror. There are two simple laws that govern this. First is the angle of incidence is equals to the angle of reflection. This is the most crucial part, which is the incident ray or the incoming light and the reflected ray, which is the outgoing light, make the exact same angle with a normal or an imaginary line perpendicular to the mirror surface. We write this as angle of incidence is equal to angle of reflection, or I equals R. The rays, so the second one is the rays and normal lie in the same plane. The incident ray, the reflected ray, and the normal is all exist in the same two-dimensional plane. Example, looking in a mirror. When you look straight into a plane mirror, your light travels to the mirror and reflects straight, right, back to your eyes, meaning the angle of incidence and reflection are both 0 degree. If you shine a laser at the mirror at an angle of 30 degrees to the normal, it will bounce off at an angle of 30 degrees. So, this simple rule is why mirrors work. Now proceed to the laws of refraction, or the Snell's law. Refraction is the bending of light as it passes from one transparent medium to another, like from air to water. This bending is caused by the change in the light's speed. The incident ray, the refracted ray, and normal lie in the same plane. 'Di ba? It's similar to reflection earlier. All three are in the same plane. Snell's law is this law mathematically describes how much the light bends. So n1 for sine of angle 1 is equal to n2 sine of angle 2, where n1 and n2 are the refractive indices of the two media. Example, your n air is approximately 1.00 and your n water is approximately 1.3300. So a higher index means the light slows down more. Angle 1 is the angle of incidence in the first medium, while the angle 2 is the angle of refraction or in the second medium. So example, the bent pencil, if you put a pencil in a glass of water, the pencil appears to be bent, right, or broken siya tanawon at the surface of the water, because this is because the light rays coming from the underwater part of the pencil are refracting. That's what we call as refracting or bending as they move from the water, your which is your n2 into the air or your n1 before reaching your eye. This makes the underwater part looks shallower and in a different position than it truly is, right? So, in summary, reflection is the light bouncing off a surface following incidence equals to reflection, and refraction is light bending as it passes through surface, governed by Snell's law.
Good day, everyone. Now let's proceed to the example problem of the law of reflection. So here's the problem. A ray of light strikes a mirror at an angle of incidence of 40 degrees. What is the angle of reflection? Here's the formula. Theta I is equals to theta R. So in this problem, it is about the reflection of light. When a ray of light hits a mirror, it bounces off at a certain angle. The angle at which the light strikes the mirror is called the angle of incidence. So that's the theta I. And the angle at which it bounces off is called the angle of reflection or the theta R. Now, according to the law of reflection, the angle of incidence is always equal to the angle of reflection. In this problem, the light hits the mirror at 40 degrees, so it reflects off at the same angle, which is 40 degrees. So here in this problem, no more long solution because as what it says, according to the law of reflection, the angle of incidence is always equal to the angle of reflection. So the final answer is the angle of reflection is 40 degrees. Next, let's go to the example problem of the law of refraction. Here's the problem. Light passes from air n1 is equals to 1 into water n2 is equals to 1.33 at an angle of incidence of 30 degrees. Find the angle of refraction. So in this problem, it deals with refraction, which happens when light passes from one medium to another and changes direction. Here, light goes from air into water, and since air and water have different optical densities, which is represented by refractive indices n1 and n2, the light bends. So in this problem, we will be using the Snell's law formula. Snell's law relates the angles and refractive indices. And now we will be identifying the given values. So N1, which means refractive index of the first medium is the air. It is the value is 1. And then the N2, or the refractive index of the second medium is the water. So water is equals to 1.33. And then the angle of incidence, or theta 1, is equals to 30 degrees. Now we will be finding the value of angle of refraction, or represented by theta 2. So in the solution, we will write first the Snell's law formula, and then substitute the given or known values, and then simplify it or solve the given values. And then we will now get the sin theta 2 is equals to 0.376. But we will not yet end there. So in order, since 0.376 is not the angle, so in order for us to get the angle, we will be using the arc sin. So now here's the formula. So theta 2 is equals to arc sin 0.3 times the 0.3776, we will get the value of 22.01 degrees. So now the final answer is the angle of refraction is 22.1 degrees. Now, that's all for my part.
In conclusion, you just have to remember these key points. For reflection, the angle at which light hits a surface is the same angle it bounces off. For refraction, light bends when it moves from one medium to another, like from air to water, and each material bends light differently. By understanding these rules, we can explain how mirrors, lenses, and even rainbows work in our daily lives. So that's all for our topic, and thank you for listening.